Alrighty, welcome back from break again. So we've got the second half of class then. So we're going to get into templates this week, and our next project should be a lot of fun. Looking forward to it. The lab that we'll have today, right, we should be able to do on templates. Should be okay. We won't get through all of the template stuff we need to. We'll get far enough to be able to do a lab on it. But we got to talk about the project as well. So I think we'll be okay to do our lab on templates. But we got to talk about project one. We fire Visual Studio here. So we're playing with our pointers and polymorphism here. So we fire up a new project. We want console app, project one. All right, got it in the right spot. Really got to edit that template here. All right, so we wanted to do a class for character with a virtual attack function that we can override later, and then a subclass of character called magic character, and we're going to change what they do with their attack function here. And then we're also going to have a class for weapon and a subclass of weapon. Okay, so using two different classes as base classes, parent classes, super classes, whatever you want to call them here, right? And then two derived classes or child classes or subclasses. So let's start with character. Now again, I like putting them in separate files. You don't have to, but that's what I like to do. I think it makes things look pretty nice here. So we'll make a header file for character. This will be our class for character. We'll have our private section. And we'll have our public section. So character needs to have attributes for name, max hit points, current hit points, dexterity, X location, Y location, and weapon. And our constructors should accept values for all of these things. And then we'll have get functions for all of them. And we only want sets for a couple of them, right? So some of these things don't change. Your name doesn't change, your max hit points doesn't change. You don't directly change your current hit points. Right? We're going to see how that changes a little bit here. And once your dexterity set, you don't change that either. But X and Y is where you can move around. We'll imagine it's some sort of 2D grid, and then it'll change the weapon that you have as well. All right, so let's grab these ones out here. Oops, so that should be our private section here. So we probably are going to use a string, right? So we'll include string, we'll use our namespace. So we'll have a string for name. We'll have a int for max hit points. We'll have an int for current hit points. We'll have an int for dexterity. Have an int for X location and an int for Y location. Oh, missing the semicolon there. Int Y location. And then the weapon itself, right, is going to be a type of weapon. And we want that to be a pointer. Because if we don't use pointers, it's not going to work very well for us here to get all that polymorphic behavior that we want. Now, it doesn't know what weapon is, so let's go just make a weapon class real quick. Make a new header file for weapon. Class for weapon. Now we can come back to that later, right? We'll come back to it, and we just need to include it then. And now the red lines should go away, right? And then E and D for formatting here, get that all lined up nice. Great. So we got our values. Right, we need a constructor that accepts all of them get functions. So we'll write our constructor first. So public character takes a string for name, an int for max hit points. I did say all of them. So you can take current separately if you want to just set current to max. That's probably easier, right? Generally, when you start a new character, you're at max hit points. Otherwise, you're just mean to people. But I did say accept it for all of it, so we might as well. Current hit points, int for dexterity, int for X location, int for Y location, and a weapon pointer for the weapon. That gets a little bit long there. Let me bump that down a little bit here. Sorry, I don't need the public word there. It's already in the public section. There we go. So then, right, by this name, it's the name, this max hit points. This is a little tedious here, but that's okay. Current hit points, this dexterity is dexterity, this X location, this Y location, the Y location, and this weapon is the weapon. All right. Okay, so we've got our constructor, we got our attributes, and we need get functions for all the attributes. All right. Let's go do this here. So GPT. I want to use the chatbot because I'm tired here. So let's class for character. Let's do this. Given class in C++, class these attributes, right? Get methods for accessing all the values, all the attributes. Something like that. We'll see what chatbot gives us here, because I don't want to have to type all that myself. I'm lazy. This way I can drink coffee while the computer types. It's very exciting. Hey, look at that. I get some good functions. Let's see if that works here. And then, right, we're going to cite our source, because that's what I asked you to do. This is from GPT, from GPT, prompt. Oh my goodness. I guess we should do that as like a code comment block then, right? How's that look? So get name, get hit points, get current hit points, get dexterity, get location, get Y location, get weapon. They added constants to all these, sure, whatever, it's fine. We're returning values here. Should be fine. Right? Certainly, what a happy, nice little bot here. Reminds you of Bob Ross. It's always cheerful. All right. Oh, it's even telling us, look at that, how nice. If it's not intended, you might need to return a pointer to a constant object or reference to a constant object instead, like constant pointer, get weapon constant, double constants. It's even telling, I love this. I love this chatbot. It's so exciting. All right, what do we need next? We need set, add set functions. Let's ask it. And this is the tedious stuff we don't need to do. Let's see if it does it for us. So we asked to do that, right? So then we'll put in here GPT prompt. It's even telling us where to put it here. Beautiful. How pretty is that? Now, do you like these comments here? I'm genuinely curious. Is this interesting to you to say setter for the X location attribute?
And it just takes up an extra line.
This is why I hate comments. This is not a very useful comment because the method is called set X location. I don't need to read a bunch of text that says the setter for the X location attribute. I feel like that's a little bit redundant, but I might be a little bit biased. And again, I've been doing it for like 20 years, so I take a couple things for granted. So my apologies if you find these useful, but it just looks like garbage. But that's okay. Like getter for the X location, Y location attribute. Yeah, it's called get X location, get Y location. I know that, but okay. All right, we're just going to copy paste because we can, right? All right, so we got those. Now we need a virtual function for attack, which accepts another character reference. Right? Okay, so we want to attack. So virtual void attack, which takes a character reference. Now, if we want all this stuff to work right, probably pointer is easiest here to use, which is a pointer is a reference, right? So we say character target. Might be what we want to call it here. So if your character has 0 hit points, nothing happens. If it doesn't have a weapon, it uses null pointer for its weapon. The range is the square root of 2. If they hit, the attack does 1 damage. If the target is within range of the weapon, calculate the distance between the character and check the weapon's range. Roll a 20-sided die. If the number is greater than the target's dexterity, it hits. If it hits, use the get damage function from the weapon to determine how much hit points target is reduced by. And then add a function take damage that accepts the value of damage take. Change the character's hit points. Don't go to go below 0, greater than max. You know, I don't think I told you what the damage should be if you don't have a weapon. Oh, it does 1 damage. Good. Perfect. We did have that here. All right, so first we need to make sure that we have hit points. So if my current hit points is greater than 0, stuff happens. Right? If not, this character's dead. It shouldn't be able to attack. We just want our little sanity check in case someone later using this class tries to do a dumb thing. Right? Who knows what users are going to try? Because they will try all sorts of funny things. So if we have hit points, right, now we need to see if we have a weapon or not. Okay, so if we have a weapon, then we need to go check that. And really, even if we don't have a weapon, we still have a range. So seems like that could be a little helper function here. Because either way, we're going to check to see if we're within range. So we can say, hey, if my target is, or I don't know, is within range given the target. And we'll come back to figuring out how that works later. We can write a private function for that, a helper function. Okay, so if they're within range, great, then we're going to do some damage. Or now we need to roll and see if we hit. So roll a 20-sided die. If it's greater than their dexterity, it hits. Okay, so if, I don't know what, math dot, is it lowercase math? Random? Rand.
Or srand.
So that would seed the random value. So we could seed it with like the system time.
Yeah.
This way it'll be the exact same sequence every single time if we don't seed it. Probably be good to seed it at some point in here. I might do that like in the whatever runs this in main or something. I might try and seed it. Not sure if we want to do that in here. So rand will give me, do I have to do mod 20 on this one here? Plus 1? I have to give the number 1 to 20 for a 20-sided die. So if that is greater than the target's dexterity, so target get dexterity, right, then we hit, then we got to do some damage. So it'll either be 1 or our weapons damage here. Right? So if that hits, then if within range, and really we can take advantage of our short circuiting here. You don't need to have an if inside of an if here if you don't want. You can throw it in here, and we could even move it up 1 more. The more we indent stuff, usually the uglier it gets. So if it's just if, a bunch of if inside of ifs inside of ifs, we might as well just put them all this way. And then if the first one is false, it won't even bother looking at the next ones, because it's going to short circuit. Right? C++ is smart enough to know you can't get a true back once you have a false and an and. So it just stops looking. So okay, so we'll add all of them in here. Great, so if all that happens, then we're going to do some damage. So then we're going to have a take damage function, right? So a void take damage function here, given an int for damage. And then take damage was supposed to accept a value and change the character's hit points. Don't go below 0 or greater than max. So we'll take our current hit points and we'll add to it the damage. And then if my damage is, if my current hit points is less than or equal or just less than 0, I guess, right? We'll set current hit points to 0. And then maybe else if my current hit points is greater than my max hit points. Then we'll say my current hit points equals the max hit points. Right, just 2 little checks. So if we went below 0 or if we went above max, stop. Right, stop at 0, stop at max.
Would the current hit points though, unless I guess if damage is a negative value, then adding it would subtract.
Yeah.
Oh, okay.
Yeah, so that's the healing stick should be a negative value, right, when we go return the negative value.
Gotcha.
And that should essentially heal them
Gotcha.
with the attack function. Sort of an abuse of making this work here. But
I think I ended up doing the opposite, where current hit points minus equals damage or something.
oh yeah, okay, I gotcha. Yep. So minus damage. Yep. I was confused.
Oh, gotcha.
Take away the damage, because then if you take away a negative number, it adds it. Yes. Thank you. I had that wrong on purpose. We were going to find that when we were testing our code.
Sorry.
Obviously. That's why we have to test our code.
Right.
Okay. So if we have hit points, if we're within range, and then we hit, right, a random number greater than the dexterity, great. So then it will be our target take damage given, I don't know, how about a get damage function? I don't know what it is yet, right? Because if I don't have a weapon, I have something. If I do have a weapon, it's something else. So these are going to vary based on if I have weapons or not. This just cleans up the attack function a little bit here. You didn't have to do that. You could do all that logic inside of here. You just have two different if-elses, right? I like having it in a separate function, that's all. And then these ones should be private functions because no one else needs to use this outside of my class here. So if I can say I want to create a definition, sure, no, where is it given to me? No, create. Come on, why is that not? All right, that's fine. I thought it would give it to me here, but we can make it in the private section. So it'll be a integer, Boolean, or is within range, given a character pointer, the target. So to see if they're within range or not is we need to know if we have a weapon to see what our range is. So if my weapon is equal to a null pointer, is it lowercase, null PTR? Okay, lowercase. So if my weapon is a null pointer, I don't point at anything, I don't have a weapon, then I'm going to have my range. So we'll have an int range. Oh, it's probably going to be a double, right? So a double range will equal math dot, is it a square root? Yeah, square root of 2. And then if it's not a null pointer, then we can change the range to my weapon dot get range or something. Yeah, we don't have that function yet, so let's go add it here. So we'll have a double for range in our private section, and then the public section we'll have a double get range returns this range. All right, so now that one should be happy. Okay, so we got the range. Now we need to see, are we within range? So I know what the range is. It's either square root of 2 or whatever the weapon's range is. So then I can return, or you can do it in more than one line, right? This will be the little distance between two lines formula. So my x is squared plus the y squared, take the square root of that. It might be a little bit long here. I don't know. I can probably do it in one line. So my x location minus the target's x location, get x location, squared. Is it pow? Is that pow? Pow function? Pow of that to 2. Right, and I want all of that, this is all going to be the square root of this is less than or equal to my range. Let's see, do I not have enough, I don't have enough parentheses yet, that's okay. So the power of this squared, right, plus the power of the y location minus the target's get y location squared to get y location with some parentheses. That's a method call, function call. All right, so power of that plus the power of that. I don't know, is that any prettier maybe? Oh, you can put it on different lines. I don't know if that helps, but square root of that. This is more of the art piece. Like, hey, how do you want it to look here? What's going to make the most sense? Sure. Some people like if you do like curly brace hanging style, like hang those off of that one. I don't know. Got lots of options. And then we can move range back up here maybe. So I think that's the right formula. Right? We're going to take the distance between the 2 points here and calculate the hypotenuse of a triangle.
I just did classic D&D where you can only attack in straight lines. Okay. No diagonals.
All right. Cool. So now we got get damage for the weapon. Determine how many hit points. Oh, that's why we didn't get our damage yet here. So now that's within range. That's the number of its hits. We got take damage. Now we need a get damage function from weapon. So weapon is we have a range. We should have an int for damage and a int for get damage. We can return this damage. Okay, so we got that one. All right, so that was our is within range. Now we're going to have the int for get damage, right? This will be our get damage for the character here then. So we can say an int damage is going to equal 1, and then if my weapon does not equal a null pointer, Right? If I do have a weapon, I'll change what damage is. Will be my weapon get damage. And I can return that damage. Right? Again, could have done this right down here below, but this sort of just cleans it up a little bit, makes the attack function a little bit easier to read. That's all. All right, so that's character here. So we've got the weapon, we got the range, we've got the 20-sided die, we have get damage, we have take damage. Okay, so I think we've got character down. I think we're good there. And we need magic character, which has another attribute for intelligence, overrides attack to use a magical attack instead of a weapon. If the target was within a range of 10, it'll do something, roll the 20-sided die. If it's greater than the dexterity it hits, it'll take damage of its intelligence divided by 3, rounded down. Okay? So let's go make a subclass. So we can make a new item, make a new header file for magic character. This is a class magic character, colon character, public character, right? Well, all the character things that this one does include character. All right, so we're going to have a private section and a public section. Now, our functions here for is within range needs, this one is going to be a little bit different, right? Because we have a range of 10, not a default range of square root of 2. This one's a little bit sad. Right? We won't be able to take advantage of this because we have a different range by default. That's okay. We can change if we want, right? So we're going to change the attack function. We're going to override what that one does, essentially. So we might be doing a little bit of work again here. Maybe we can have just this distance pulled out. This might be nice to pull out just the distance piece as a function we can use. That one might be nice. Just to, right, if we have the same code twice, we feel bad about ourselves. It's a pretty good rule of thumb. So we're just trying to think of how we can not have the same code twice. All right, but anyway, so we got intelligence. Probably want to take that in the constructor. I didn't specify. However you wanted to do that was fine, but if character has a constructor that takes a bunch of values, we know we need a constructor that takes a bunch of values. Is I need a way to give those to my character constructor to make an instance of magic character. So I'm going to take all of their constructor things here. So this will be my magic character. We need all of those things, and then we also want an int for intelligence. Probably good there. So we have an int for intelligence. Intelligence. It's really embarrassing that you can't spell the word intelligence, but I think I got it right. There's 2 L's, right? I think there are. That looks right. Okay. I'm bad at spelling. Right, so to call our superclass constructor, right, it's telling us, hey, right off the bat, as soon as I finish my constructor, there is no default constructor for character, right? So we use our colon notation, and then I can pass it all of those things here. So we'll have name, max hit points, current hit points, my goodness, what is this? Dexterity, X location, Y location, weapon, right? We're going to pass all of those to our character constructor. Character. So ask for them here, so I have something to give my superclass constructor. Right? Then I'll set my this intelligence to the intelligence. Okay? Cool, so now we got our constructor. Now, again, I think this distance might be nice to move out as a separate function. I think, do I have the option here? Can I extract? I can extract function, here we go. So distance to target. So I just grabbed all that code and right-clicked. I did my quick actions refactoring. It'll turn it into a function for me. So this is a, now I don't want this one to be private though, because I want to be able to use this one again. So remember there's that second or third option. We had private, we had public. There's also protected. Protected means you get access in your subclasses. So I want my subclasses to be able to use this function here. So I'm going to move this out to a new section here for protected. Protected. Put that out here. So now I can use my distance to target in my magic character class when I override the attack function. Right, so we're going to add an override, void attack, given a character, reference the character, the target. Nope. Did I just say? Do I not need to add the override?
I think override's after
Override.
the parentheses.
Oh my goodness. Okay, add it, sure. Why not? We put it in the front in C#, so. Syntax is fun. All right, so we're going to change the behavior of attack. So what is different about attack? Well, some of the things are still the same, right? So if we have hit points, target's within range, right? Is within range, cool. But so is within range is figuring out what my range is as well. But still doing most of the same thing here, so this is good. It's within range, and then the random value. Okay, so we'll take most of this here. So if my current hit points, so I don't have direct access to this, right? So I need to use get current hit points, which will get my current hit points. And then, now the is within range gets a little funny here, right? Because we want to use a magic attack instead of the weapon. So we're just a range of 10. If your magic character also has a weapon, I didn't tell you what to do here. My apologies. You could have picked something, or you could have just always used your magic attack. Because if you have magic, why would you use a regular weapon? Like, if we could actually do magic, I think we'd be doing it all the time. So why not? So sure. So my distance to target then, distance to target, given the target, if that is less than 10, right? So we said our within a range of 10. Okay, so within is probably less than or equal to range of 10. Sure. Roll a 20-sided die. If it's greater than the dexterity, it hits. Oh, we still have the same 20-sided value. I feel like this should be another function too, because I have the same code twice and I feel bad about it. So let's take that out. Where did that go? That's an R attack here. Let's turn this into another function. Just this piece here. So let's quick actions refactor. Let's extract function. Let's see, I don't know what, roll. Yeah, attack roll. I like that. Sure. Now we get an attack roll. So then I can cut that out. I can say attack roll given the target. Okay. And why is that upset? Why are you mad? Oh, missing a closing parenthesis. There we go. Now I don't have a get damage, right? I'm going to do my intelligence. So I need to floor, right? Floor is for rounding down. My intelligence divided by 3. Okay, so floor should round it down. Or any other way you wanted to do this, right?
If damage is already a
oh, it is an integer, right?
int, it would just automatically.
Yeah, okay, yeah, we don't even need to round down, right? Because integer division takes care of that for us. Thank you. Awesome. So they take some damage based on our intelligence divided by 3. I think that's it for magic character. Right? I think we got what's special then is our attack. Our attack does a different thing. And then again, our constructor. There's not a lot of code in this subclass, right? Because we're only changing what's different. And then again, the goal was to not have the same code twice. Totally optional. You don't need to do any of that stuff. The distance to target. We could even add like an is alive if you want to get super fancy. This doesn't feel like you'd save a whole lot of code, but why not, right? Let's go nuts here. Current hit points greater than 0. Let's extract that. Extract, and then we'll call this is alive. Sure. Oh, so attack roll probably doesn't need to be public, right? Let's move that back to protected, just to clean this up here. And then is alive is probably fine to be a public function, right? Nothing wrong with that one, whether or not we're alive or not. So I think that one's pretty good. So this will be is alive. And the distance to target is less than 10, and my attack roll. Now, 10 here is a little bit messy, right? So we probably want some sort of value here. Maybe, I don't know, static int, static constant int distance is 10. I like that. Look, trying to clean this up here. Now, intelligence divided by 3, I don't know if there's a great way to clean that up here, because that was just what we said here. I don't know, we could have this be a function for, like we had a private function for get damage. We could do that, and maybe that's a little bit better to put a divided by 3 in, get damage as an int here. Turn intelligence divided by 3. Oops. This feels a little bit silly, but that's okay. Could probably do that. Again, I don't know, divided by 3, this is a little tough. Like 3 doesn't really mean a whole lot. I don't know, like damage adjustment. I don't know. You can maybe come up with something nice for it here, but not a whole lot there. Oops, save them. I hit my Control S habit of saving my file. Does not work well in the browser, turns out. All right, so we got all that. I think we're good with our characters. Right, now we got to move on to weapon. So weapon has an attribute for name, max damage, and range. Oh, it's max damage, oops. All right, so let's do our weapon here. So it should be max damage here. And then get damage is actually supposed to be different, right? Get damage should be between 1 and max. So it's okay that this didn't actually do what it was supposed to do yet here. So we want a random number mod the max damage plus 1, right? Right, so that should be between 0 max damage and then add the 1 to get between 1 and max damage. Cool. So then we need probably a constructor. We were supposed to have a string for name, right, as well. So let's include string. Usually it works without that. It's super weird, but that's okay. Using namespace standard.
Would there be any issue with you having in here a function for get damage, but then in magic character having a function? I think it'd have the same name. No, because it depends on what object, what variable you're trying to use the get damage function on. So weapon.get damage is different than your character arrow get damage. Yep. So we want a string for name and a double for range and an int for max damage. And then we set all of this names to the name, this range to the range, and this max to the max damage. All right, get range, get damage, maybe get name, string get name, turn name. Okay, let's see. Virtual function for get damage, that's right. Okay, so get damage should be virtual because we want to override this, right? We want to be able to change this behavior later and have all that polymorphism stuff work, which is the fun piece here, right? If we plan ahead and make these things virtual, I should be able to make as many subclasses of weapon as I want. And I can just go nuts here and change the behavior of get damage to be anything I want, right? Magic weapons, healing sticks, spells, I don't know, you can come up with any sorts of crazy things you want here if you're having fun in your fantasy world like I am here. I'm imagining all the endless possibilities here. Sound good? So I think we're okay with weapon. And because the function is still called get damage, we changed the behavior of it. But as far as character is concerned, it doesn't care. Get damage returned an integer. That's all we knew was supposed to happen, right? That's the idea. When we build out classes, this idea of abstraction is that function will give me back a value. I don't know how it does it. I don't need to know the details of it yet. I get to work with the abstract piece of it here. That's why I like object-oriented programming. It's why it's very popular in the industry, because it lets us break these things apart and not have to know about the details here. Say, here's the abstract thing I get to work with. Great, here's a function, it's named this, it gives me something back. I've got a contract. I'm happy to use that contract. I will work with that. And you can change it anytime you want. You can change the behavior, you can tweak it, you can make it always be 1, you can make it be 100, whatever it is. You just tell me what the damage is, and I'll use it as we start designing our solution. So works out pretty well to do things this way here. And again, not everything needs to be virtual. But we can always go add it later if we want to, but we know we're going to override weapons, so or make a subclass of weapon. So get damage makes a lot of sense here for that one. All right, then we got range, great. And then subclass of weapon is our healing stick. We will override and return a negative value. And I didn't even say what, so maybe just the negative of the parent version is probably fine. And oftentimes when you are solving problems in the real world, you don't get a very detailed written spec that says, this is the way you solve the problem, this is what it looks like. You get a description of what the problem is, and it's up to you to figure out how you think that should be solved. There's a lot of interpretation there. Generally, you have someone you can go ask, like, well, what do you mean if it's supposed to allow the user to do this? And then they'll tell you more information about it here. Again, none of you said you watched Office Space, which makes me very sad, but that's okay. Depending on how large your organization is, there are people in between the users and the programmers, because our general school of thought is programmers aren't good at talking to people. It's a bit of a bad stereotype, but again, large organizations, these sorts of divisions make sense. So someone in the middle, we generally name them like analysts or business analysts or systems analysts, are the people who talk to the users to figure out what the users actually want. Because the users just want something to happen, but they're really bad sometimes at giving you all of the rules. Okay, if this is the case, then this piece happens here. Oh, well, if this, if it's sunny out, then I have to do a different thing here, or whatever there's all sorts of different cases that could happen. So there's a lot of variance here. So I'd like to give you vague pieces here to practice some of that. It's good practice here, because programming really is an art as much of it is as a science, right? The science piece is interesting and fun and all, and we got to speak compiler. But the art of it is, how do we solve problems? How do we approach problems? How do we think about problems and break them down into small pieces? Do our functional decomposition, my favorite buzzword, go throw that out at your St. Patrick's Day party and just have everyone look at you like you're nuts, which is okay. We're computer science people. We're all nuts. So that's perfectly fine. We can just embrace that, right? So we're going to write the healing stick here. Sorry, got off on the deep end there. So this is our class for healing stick. We are a public weapon here. We have, we got to include weapon, right? So include weapon. Again, I like one file per class. I think it keeps things nice and clean in source control, because I can see when that specific class changed. It's just a habit here. C++ doesn't really care. And putting everything in the H files, again, is a little bad. I apologize. This will slow things down in larger projects. There's some really cool nuanced stuff that C++ does when it compiles. There's a lot of things we just take for granted when we hit the run button when it goes and compiles. I think I mentioned this before, but it's worth pointing out again. When you include an H file, it's essentially copy pasting. So every time you compile, it has to go out and copy paste everything here, which can be a little bit slow, because then it has to go and compile all of this class code again every time. If you use an H file that just has the function prototypes, just the definitions, and a separate CPP file that has the implementation of it, when you compile, if that CPP file has already been compiled and there were no changes to it, the compiler will skip compiling. When you include the H file, it just grabs the prototypes. There's nothing work for it to do for the compiler aside from say, okay, you asked for a function, it has this name here. It matches. It just does a quick, you're using it right. It doesn't have to do any work to generate those object files, the code files that get created. Remember back when we did our Unix thing, we had to learn the CMake to generate files and all that fun nonsense. So it saves time to break them out. It makes it harder for us to test. You can test them still, but you have to click a bunch of extra buttons. It was no fun when I tried to make my class do that, because then they got confused about the 15 different things they had to click on and press, and I got tired of explaining it. So I'm just gonna be lazy. We're throwing everything H files, but it's bad. So if someone else tells you not to do that, just great, smile and nod, it's okay. We're just gonna be lazy for now. Anyway, so for healing stick then, we're going to override our get damage function. So we need a constructor, right? Because we have to be able to call our weapon constructor here. So sure, we'll just take all these same values, I guess. So for healing stick, so a private section, we really don't even have anything private, right? There's nothing here. So for healing stick, here's our set of attributes. We'll pass all of those right over to the weapon constructor. Given name, range, and max damage. Right, there's like nothing for us to do. We don't have any attributes here. And then we're going to have a void get damage. Oh no, an int get damage, right? Int get damage function here. Now what get damage is supposed to do is give you a negative number. So really I can get the weapons version of get damage if I want, right? So I want to use my super class. I want to use my super. Is it super? Super get. Oh my goodness. Weapon. Oh my goodness. Why can I not remember? Plus super class function. I'll just Google it here. Oh, parent colon colon. Okay, so weapon colon colon get down. Okay, that's right. Our little scope operator, the double colon, because why not here? Times -1, and we'll return that.
and we've got to mark this as an override. Right? So just get damage from our parent class, superclass here, and then turn it negative. So whenever get damage happens, because all of our code, when we attack and things, says, hey, if you're going to hit, subtract the amount of damage. If it's a negative number, now boom, we've added. And life is good, right? Nothing has to change in character, which is kind of fun. Again, a little bit of an abuse there, but that's okay. We can handle that, I think. All right, and that's the healing stick. Okay. Why? That should have been character. Did I change that?
I was wondering.
Sorry.
I was like, I don't know if I got that.
Character class.
Whatever the heck the description
Sorry about that.
criteria means.
Yeah, that's character class. Magic character, weapon class, healing stick, and then unit tests. Oh, I did one. Someone had asked about unit tests. I don't remember if I ignored them or not. So weird break. My apologies. Because we want to know if it works. Right? So for unit testing, there's not actually a lot here. Right? Unit testing random stuff is a little weird. We don't really know how to deal with this yet. We can seed it to a fixed value, and we know what that sequence should be. It's a little bit wonky, but we can do it that way. Or just, hey, is the number between 1 and this? It should always pass. That should be fine. There's a couple ways you can mess with that one here. Again, get methods are really obnoxious to test. We don't really need to test those specifically. But if we test the constructor and then the get, gives all the values that I gave it, we're testing constructor and get at the same time. Great. And then other things we want to make sure that they work, right, are the actual interesting ones like attack and take damage. Right? So we can write some tests for it here. So let's try character first. Say go to, where's my test? Oh my goodness. Do I have to add it separate? I thought I had a go to. I don't. Didn't I have a create test? I'm so fuzzy right now.
I think it was.
Want more break.
Just watched this, or that recording yesterday. It was like create a new project and then.
Yeah, do my okay, yeah, I'll do my project first. There we go. So I add a new project. I'm going to add a test. No, come on. Test. Filter first. Unit test project. Project 1 test. Again, the name doesn't really matter much. It's okay. All right, yeah, okay. I just did them all by hand here. There we go. So we're going to include, right, now to go up a folder, right, is ... Then back into project 1, then character, right? I have my character test here, right? So this will be test character constructor. Great. Okay, so we're going to arrange, we're going to act, and we're going to assert. So all the things we expect to have, right? So we expect to have a bunch of these things here when we go get them. Sure, we'll go make a bunch here. String for name, yeah, all those values. So name equals, I don't know, name. Max hit points is something. I don't know, let's do like 10. Hit points is 10. Dexterity is 10. Why not 10s for all of these here? We like 10s, right? 10 semicolon, not an L, please. How about a null pointer for now? We'll figure that part out after. All right, so these are all the things we have or we expect, right? So maybe an expected name. If you don't change the names of all of them, that's okay. I just get a little silly about it sometimes, I guess. Okay, great. And then act. If we're testing our constructor, we need to call the constructor. So we'll have a character, given all my values here, right? So my expected name, my expected max hit points, my expected current hit points, my dexterity, my X location, my Y location, and my weapon. Great. Oh no, expected weapon, sorry. That's why I forgot about that one. It's a little long here. If your font's not super zoomed in like mine, it probably fits on one page, and that's okay. And then again, we'll have a bunch of actuals, right? Now these are all going to be the actuals. So let's do a find and replace here with actual. Save a little bit of time. So I don't want to replace all, I just want to replace some of them. Right, so this will replace the current one that's highlighted. There we go, and then stop. I don't want to replace all of them, so it just saves a little bit of time. That was Control H for find and replace. You can go to the edit menu for find and replace. Right, that's the quick replace here option. It's a fun little shortcut. And then all of these now will be my character dot get name, character dot get on all my get functions here, right? Gets, get max hit points. Come on. Where's my type ahead? Probably should have had the word get in there. Get my current hit points. Get my dexterity. Get my X location. Get my Y location. And get my weapon. Great. So call the code we're testing, and then get all the values we want to check. And that's what we do in act. And we're going to assert. So that's assert equal. Assert equal? No. R equal? Oh my goodness. Assert colon colon R equal. There we go. My expected name and my actual name. Right, we just have a bunch of R equals here with all these different ones here. So expected name, and I'll just do copy pastes because maybe that's fast here. So double click to copy, Control C. We get current, dexterity, X location, Y location, weapon, weapon. There we go, and then actual name, great, actual hit points, actual current hit points, actual dexterity, actual X, actual. Once we've got one, this will be a lot faster because we can copy paste the rest here. Oops, didn't double click right. All right, and we'll assert they're all equal. So this test we would hope passes, right? If I give it a bunch of 10s and name here, I should get them all back out. So we can try it. So let's run our tests. Go to the test menu, test explorer, and run some tests. Oh, there are build errors. What did I do here? Whoa, that's a weird one. What was my error? ToString for your class. Where? Class weapon. Oh, it doesn't like that the pointers are the same here. So checking to see if a weapon pointer matches a weapon pointer. It doesn't know how to compare those two. So I think, probably say, say is true. Say is true. My actual weapon is equal to, or my expected weapon is equal to the actual weapon. I think I can do it this way because I can use the equals operator. I think I don't think I can use the R equal method here, the function here. Let's try that. Test Explorer. See if that one's happy. Well, it should just compare the memory addresses here right now, which is a little silly, but they're null pointers, so that's good. Hey, the test's passed. Hooray, that was exciting. All right, so now we got that one. The other interesting piece then that we want to test, right? Other actual code, aside from that then, we had was, we could test the sets. I don't care too much. We probably should actually be using those in here, just in case, right? That would kind of do all that for us. So if I say set X location, given the X location, now look, hey, we're testing the set function too. That's set Y location. It's sort of cheating, but that's okay. I'm happy with it. Set Y location and set weapon. Given weapon. Look, now we've tested the set methods too. Those set methods run. If we're talking about code coverage, the idea is my code running when my tests run? Then sure, yeah, now all the set method codes are running. The set method code is running. And sets and gets are kind of boring to test. So just lump them all together here. The interesting pieces though, for character, we do want to test. We want to make sure that attack works and take damage works. So to get 100% code coverage here for take damage, I need this block of code to run, and I need this block of code to run. So I probably want 2 different tests, right, for take damage. So we're going to make 2 different tests for take damage here then. This will be take damage, character, take damage. So I don't care about all these other values here. I can leave them, I can throw them out, it doesn't really matter, but I don't need all the gets here. All I really care about is their actual hit points at this point, right? I don't even care what their max is. So do their hit points change here? I don't need name either. Let's get rid of name. So technically, we're not testing the constructor, so I'm going to move the constructor code up to the arrange section. We're not testing it. We're only testing the hit points here. So to make sure that I can actually take some damage then, I'll say character dot take damage. Now, what do I expect my current hit points to be? So I'm going to give it the max here. So I'm going to start current at max, and then I expect it to be no less than 0 here, right? If I take like 100 damage. Or I don't know, we'll say like max times 2. If I take double my max hit points, I should still stop at 0, right? When I'm done. It should be at 0. No less than 0. Okay? And then we'll do another one of these going the opposite direction. So now I should stop at my max hit points if I start at, well, I don't know, I'll just put us at 0 to start, right? So my expected then should be 10 as well. So if now I take a negative value here, negative that, right? It should stop at my max. So if I start at 0 and I take negative double my max, it should go up, but stop at the max here. Right? So between those 2 tests then, this block of code should run the first time, this block of code should run the second time, right? That's what I wanted to test here. So let's try that with our test explorer. This is where I would have caught my addition versus subtraction issue. Oops. Oh, there we go. Take damage, negative. Take negative damage. There we go. Can't name the same thing twice. And they pass. Life is pretty good. So take damage seems like it works. Okay, that was the easy one. Now attack is the slightly harder one. So to get 100% code coverage, I need is alive to run, I need is within range to run, and I need attack roll to run. And this gets to be really tricky because how do I know if I'm going to get a number higher than their dexterity? Well, I can put their dexterity at 0. 1 to 20 should always be more than 0, right? Assuming everything else was fine. So I don't want the random piece of it here. I just want to make sure that it works, that it does what it's supposed to do, right? Whether or not attack roll really gives me a random number from 1 to 20 is not the most important thing here. We don't really think that, I don't know. That one's not really what we're testing, right? Because we essentially know this should work. Now, it'd be good to test it somehow, but I don't know, like we might have typos here. So this one's a little bit harder to test because it's based on random, but that's okay. All right, so we're going to do another character then. We will have attack. Character attack. So we need 2 different characters now, right? We need a character and we need a target. We could technically attack ourselves if we wanted. Right? Nothing says we can't, but just for fun, we'll have a target. So let's set both of us then at 10 hit points to start. Or no, we'll set our max. So then if we take a damage, we should go down from 10 to 9, right? So I'm not going to call take damage directly. I'm going to say attack the target. This calls attack on the target. Now I want to change that dexterity then to 0 to make sure that I will always hit, right? So I should do 1 damage. If we're in the same X and Y location, definitely within range, right? Here's the target. Oh, we want a pointer here, right? So that's the reference to the target. Is technically a pointer. The memory address is a pointer. We don't need like a special pointer variable. This stuff gets really screwy when you start doing these things, but I think that ought to do it here. So we're attacking the target, and then I want this to be the target's get current hit points. The target should take the damage. All right, let's try that one. Hey, it seems like it worked. So their target's hit points was 9 when we were done. That seemed to work. So in terms of code coverage, all of the code is running.
Now, did we really test that like is within range works? Not really, because I never made sure that if they were not within range, it couldn't attack. Right? So I might want to have one, right? Again, all the code's running already. No, but just because the code's running doesn't really mean we feel good that it's working here. So I'm going to put this back to 10 here. So if I'm not within range, so let's set the other one here now to like x location, how about times 2, or y times 2? Put it out of range. Right? That should be 20 here. So definitely not within square root of 2 distance here. So my hit points should not change because I shouldn't be within range. Right, so let's try that one here. Seems like it passes. So again, feel a little bit better that it's working here because I'm making sure that I get back that false here at some point, right? Now, the line of code ran anyway, but I sort of want to make sure, hey, it's behaving like it should. If you're not within range, it doesn't work, that sort of thing. Just some options there. All right, so for character, I think we've got it all tested, right? I think all of it was tested here. Our take damage, our is alive was being used inside of attack, is within range. The attack roll, great. Sets, great. So magic character, what is different about magic character? Well, their attack is different. So let's do a magic character, see if their attack is different. So let's test a attack for magic character. Let's do a magic character attack. Now, they can attack a regular character as the target here, so that's fine. So how about we do a magic character as our character? We want a include. Oh, I think I can just include magic character. There we go, because it includes character as part of itself, right? There we go. So magic character then needs all of that stuff and then an intelligence. So let's say if our intelligence is 10 here, or maybe we make a variable for it here. So int expected intelligence is 10. Did we add a get for it? Oh, we never did. We probably should have had a get for get intelligence. Right? I didn't tell you to do it, but it probably makes sense, right? Get intelligence. Return intelligence. I'm not going to bother testing that, but again, it would be a good idea too. It's fine. It's not really worth it here. So expected intelligence is 10. So when my magic character attacks the target, then 10 divided by 3, rounded down, should be 3. So their expected hit points should be 7. Right? If I start at max of 10, 10 minus 3 should be 7 by the time we've attacked, if we're within range. Right? So range was 10. So 20 here should be fine, actually. That should be within range. I'm just going to put them at the same spot. Or maybe we put them further out. Maybe that's fine. Let's see if that one works. Let's run our tests. Hey, all right, so that one seemed to work. We are running out of time. I'm sorry. Shoot. We haven't even talked about templates. What did we talk? Our lab was on recursion, right? Okay.
8 queens.
Yeah, okay. Shoot. Kind of want to have. I don't have enough time to show you anything new for lab. Should we just skip lab today then? We don't have nothing new to work on. I can talk about the next project. So I'll show up if you want to talk about the project. We can do that for your lab time, but I won't have a new lab assignment because we haven't done anything new yet. Is that okay? So I'm going to leave off the tests for weapon and healing stick. Is that okay? We would come back to those later, but we're running a little low on time here. So let me go commit this. All right, for 200. Not my stupid console app that I was playing with. Project 1. Project 1 to do tests for weapons. All right. I'm sure I'll notice that in a comment there. It's gone forever now. No one will ever see it again. All right. Cool. Oh, and then we got to do midterm review too. I'll post the sample midterm, or I'll post last year's midterm. I'll just turn it into a PDF for you. It's quiz questions and 3 short answer questions. So I'll post that because that's what we're doing. Oh no, I'm sorry.
we're not doing the midterm for a while. I pushed ours further out because we got to get through more content.
Quiz on this Thursday. On recursion.
Yeah, the quizzes do the stuff. Okay, just the quiz. Yeah, so we'll do the midterm later. That's right. I can remember things. Definitely need a little more coffee. All right, so next project. Let's do project 2. So this one will be on recursion. And this will be a little checkers project because checkers is lots of fun here. So 2 weeks from today puts us out to the 19th at 9:30 a.m. Why don't you folks take a morning class? Bunch of weirdos. All right. Did you start registering yet for, is anyone doing summer classes or are you looking out for fall already?
I have to see what classes I need to take or even in the summer first.
I just got the fall draft because that's going to go live soonish for you folks to see. So I know who's supposed to teach what. This is project 2. So my C++ template. C++ template. All right. So we're going to do a little 2D vector or array, if you'd like, because it's a very fixed size here, and see if we can't calculate for checkers here. Let me submit the URL of your repo and a self-assessment using the rubric in the README. Okay. Let me go steal it here real quick. Checkers. This one here. All right, so we're going to make a checkers solving piece here, 2D vector or array. So we're going to use backtracking recursion. There are ways to do this without using backtracking recursion. Please don't do that. Right? The whole goal of this was to practice recursion. We want to practice the recursion piece. We don't want to do any of the fancy stuff that's not recursion. Backtracking recursion is not the most efficient way to solve problems, but it's a nice, easy way for us to illustrate recursion and play with it here. So we're going to make a 2D vector for the board here. So it's an 8x8 board, a checkers board. There's black squares and white squares here. We're going to assume all of our pieces are kings, because in checkers, kings can move backwards, regular pieces can't. That gets really confusing to figure out if a piece is a king or not. So we'll just assume they're all kings. We'll have a B character for black pieces. We'll have a W character for white pieces. We'll have just a space character for the empty spaces on the board. Right? So this array of char, right? These are just characters here. And then we're going to have our constructor method accept the board. So we're going to make like a checkers solvers class here. So we're going to have a class checkers solver or something. We'll accept the board, make sure it's a valid checkers board. So that means the board is the right size, and then all of the pieces are on the same color. I don't actually know if they're supposed to be on the white or the black squares, but all of them need to be on the same color square. Right? You can't have a piece that's not on the same color because then you can't jump over it in checkers. So because we're just taking a 2D array or 2D vector, we need to go make sure that all the pieces are on valid spots. Right? So find the first piece and then use that color that it's on essentially to make sure all the other pieces are on that same color, if it's valid or not. Otherwise we're going to, have we done exceptions yet? We didn't get to exceptions yet, did we? Okay, that's fine. Checkerboard. I'll print an error. Printing an error is so dumb, but that's fine. That's all we got. I'll feel bad about it later. And then we're going to have a function for get max jumps here that returns the maximum number of jumps any white checker can go. So for every white checker, calculate the maximum number of jumps it can go, return the max of that. So I got to find all the white checkers, see where they can jump. So if you imagine a checkerboard here, so checkerboard, just want the image, right? Imagine there's some pieces here. See how far they can jump. So let me actually, I'll steal this like this. Let's put in my snip tool. Come on, where's the snip tool? Oh, it hit it because I'm in mode here. There we go. Do not disturb mode. That's so nice of it. All right, so we'll imagine we have some checkers, right? So let's, probably red's fine. So we had a black checker here and a white checker here
a black checker here, and a black checker here, and I don't know what. How about a black checker here? Right, and then maybe we'll do another white checker over this way. Okay, so if we want to say the maximum number of jumps any white checker can go, just a simple way of, if we're going to make a computer for this, it'll probably want to do the max number of jumps. Again, that's not really the best checker strategy, but we're going to go with it, right? Because real checker strategy would be a little harder for us to write. So the first white checker we find, starting at row 0, index 0, right? Because it's two-dimensional, we're going to find is this one here. So we're going to try all the different jumps, right? Backtracking recursion says try it. Once I reach a dead end, undo. Right, take the step back and then try the next possible option. Right, we did the maze solver. We said, hey, go up, 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 or up, down. What do we say? Up, right, left, down, or up, right, down, left, or whatever the sequence was. Once we hit a dead end, okay, we marked off. We tried up. Now let's try right. Right. So maybe we go up left. So we jump up left here. Right. So we'll jump over here and we'll erase the black checker and the white checker. That was one jump. Can I jump anywhere? No. Okay. So one jump. Let's undo. Right. So get rid of that one here, put the black checker back, put the white checker back. We tried up left. Now let's try up right. All right, so let's jump over this way. Erase the black checker and the white checker. All right, well, that was one jump. Do we go anywhere else? No, we're done. Okay, so undo. Put the black checker back, put the white checker back. All right, let's try this direction. All right, let's jump here, erase the white checker and the black checker. Can I jump anywhere else? Yeah, okay, let's jump somewhere else. So jump this black checker, now the white checker goes here. We had two jumps, now undo. Okay, well, undo. So put that one back. We had the black checker here, a white checker was here. Is there anything else we can jump? No. Okay, undo again. Sure, undo again. That was here, sorry. Black checker. I had it backwards. And then we had it here. So this white checker, the maximum number of jumps this one could go was 2. Now let's check the next white checker. All right, here's another white checker. Try and jump. All right, let's jump this way. So jump, change the board. Do we have any other jumps? Sure, there's another jump over here. Jump here. Okay, take those off the board. Anywhere else we can go? Sure, yeah, we can jump over here. Jump this way. Take those off the board. Anywhere else we can jump? No, okay, undo. So put the black checker back, put the white checker back, undo. All right, anywhere else we can go? No, so undo again. Oh, leave that black checker, sorry. Put this black checker back, put the white checker back here. Anywhere else we can go? No, okay, undo again. Right? Take that one off, put the black checker back, put the white checker back. Nowhere else we can go? Okay, that max jumps was 3. So the maximum number of jumps for any white checker on this board was 3. Right, so there's different scenarios we're going to get based on what's on the board. Right, so I should have asked if everyone knows how to play checkers. Sorry. You jump over pieces diagonally. That would have been important information to start with. Apologize. So this is why, like, they all have to be on white spaces, so you jump over them diagonally. So you need to jump over a piece, and you take that piece off the board once it's jumped over. That's how checkers works. So you jump pieces. So you jump in diagonals. So there's no left, right, up, down. It's diagonal left, diagonal right, diagonal down right, diagonal down left. Go in those 4 directions here. And then you just keep on jumping. So that the longest sequence of jumps you can get generally is pretty good, because you want to remove all of your other opponent's pieces. That's the goal of the game here. That's checkers. Okay? So that's what we're going to be working on for the next project, using backtracking recursion specifically. All right, so we'll do 5 points for, let me add the rubric here. So this is project 2. Use this for grading here. We had checkers, solver. What do they have in here? Accepts the 2D list. Okay, so constructor accepts the 2D array or vector and validates it for 5 points. Can find longest jump for single white checker. So if you just do it for 1, 5 points, and then can find longest jump for all white checkers. 5 points there. So the undo step here is really important, because if you don't put the board back to the way it was before, when you start trying to jump at the next piece, you're going to be really screwed up here. So if we went this direction and said, okay, my white checker jumped here, and I took these ones off, and then my white checker jumped here, and I took these ones off, if I don't undo that, when I come to the next piece, it has no jumps. But remember, because we're testing from the way the board started, we need to put the board back. So after we've tried as far as we can reach a dead end, we have to undo those steps. Like with the 8 queens puzzle, hey, I have to take the queen off. It can't go in that space because it wasn't a valid solution. Take it back off. So the take off here is a little bit extra, right? I have to move the white checker back to where it was and put the black checker back. But essentially it's the same idea, right? I'm just undoing the changes that I've made, okay? All right, sorry to hold you over here. You folks take care. So no lab assignment, we haven't done anything new, but if you want to show up and talk about the project, if you want to show up and talk about anything, go for it. We've got that time if you want it, but sorry didn't get a chance to get to anything new, okay? All right, I'll see you around.